Hey everybody. Alright, as promised, let's think about how the right ascensions and declinations of stars on the celestial sphere influences their position and our ability to observe them. So let's start off with these questions here on the first page, on page 17. Right? If you are standing on the North Pole, so you're standing right there, right? If you're standing right there, where is Polaris going to be? Well, I mean, it probably seems trivially easy to you, but I want to add a little extra detail here, right? Because remember, what is the horizon? The horizon it's the points on the sky right out in front of you, right? Wherever you're standing, the horizon is perpendicular to your position, right? Out there in front of you. So we can translate between location and horizon like that, right? Wherever you're standing, the horizon is perpendicular. And so here's the dome of the sky above your head. And then where's Polaris? Well, you already figured that out, right? Polaris is straight up over your head, right? If you're standing on the North Pole, then the North Celestial Pole and the North Star are at the zenith. They're straight overhead, right? What if you're standing on the equator? Well, let's rotate our view here, right? If you're standing on Earth's equator, like that, now your horizon is out there, right? Your horizon is perpendicular to where you're standing. So you're standing there, the horizon is out here, and now where is Polaris? Oh, Polaris is right on the northern horizon, right? If you're standing on the equator, then the celestial equator rises in the east, goes straight up over your head, and then sets in the west, right? It goes over your head. But the North Star is going to be right on the northern horizon. Okay. And what's the third question? If you're in the US at about 45 degrees, so let's try to get that. All right. How about here? Okay. If you're standing there, then your horizon is out here, right? And then where's Polaris now? Oh, it's about 45 degrees above the northern horizon, right? If you're standing right there, the zenith is up here. So the zenith is there. The North Star is up in the north. It's up in the northern hemisphere. Sorry, it's up in the northern sky. About 45 degrees altitude due north. Where's the celestial equator, though? Here's the more interesting thing. If you're standing right there, and here's your horizon, where's the equator? Well, the equator rises in the east, goes up here, and then sets in the west. Well, where is here? Well, if this is north on the horizon, this must be south. So if you're in the US, right, if you're in the continental US at about 45 degrees latitude, then the North Star is up there, and the celestial equator goes through the southern sky, right? When the celestial equator is highest in the sky, it's going to be due south of you. Notice what I just said. Because we're in the northern hemisphere, the celestial equator is due south of us. It's always going to be up in the southern sky. Never the zenith, right? Where do you have to be in order for the celestial equator to be on the zenith? You got to be standing on the equator. Okay? So that's a good start. Let's pick it up from there. No questions on the next page? Yep. Okay. How about this? All right. So here we're zooming in on the patch of the celestial sphere around Orion's belt. All right. And that star right there, the westernmost of the stars in Orion's belt, is Mintaka. And so what is the right ascension of Mintaka? Well, right ascension, remember, right ascension tells you where a star is east or west around the celestial equator. And realize that right ascension increases going this way, right? Right ascension's a little weird, right? You'd think, sort of our instinct with graphs is, a graph should increase going up and increase to the right. Well, no, right? Right ascension increases as you look east, so as you look to the left. Why does it do that? Because that's the direction the sun moves, right? Every day, the sun has moved a little bit eastward around the ecliptic. And so when they were setting up, hundreds of years ago, when they were setting up the right ascension declination coordinate system, they said, okay, declination will increase as you look north. Okay, simple enough. That's the easy part. But let's have right ascension go in the same direction that the sun moves over the course of the year. So since the sun moves a little left every day, right ascension increases to the left, to the east. So what that means is if Mintaka is right there, and, Mintaka is right about at that. No, too far to the left. All right, let's see here. So Mintaka is right about there, right about that right ascension. So right in between 5 hours and 28 minutes and 5 hours 36 minutes. So that's what's right in the middle there, 5 hours and 32 minutes. Okay. Declination. What's the declination? Well, Mintaka is just south of 0 degrees declination. What is 0 degrees declination? That's the equator. That's the celestial equator. Right there. So it's just a little south of the celestial equator. Here's -2 degrees, -4 degrees, -6 degrees declination. So if this is 0 and that's -2, then that's -1 degree declination. And Mintaka's not even there. So I'm going to say, it's in between 0 and -1. I'll estimate -0.5 degrees declination. And the negative is important, right? Because the negative tells you got to be very careful with positives and negatives in declination, because negative means it's south of the celestial equator by half a degree in this case. Draw a dot on the map at 5 hours and 52 minutes and -5 degrees declination. So 5 hours, 52 minutes right ascension, -5 degrees declination. There we go, right? So there's our location right there. Will Orion's belt be visible in the winter or in the summer? Oof, okay. Now we're getting a little tricky. Let's think about this. Remember what I said when we were talking about Tool 4, is when you say, when will something be visible? When will Orion's belt be visible? Well, at nighttime, right? Because if it's up in the daytime, you can't see Orion's belt in the daytime because the sun is out and the sun is too bright and the blue sky is blocking our view. So we want to see Orion's belt at night. So what the question's really asking is, will Orion's belt be visible at night in the summer or the winter? Well, what season it is depends on where the sun is, right? Because the seasons are all about the sun. So let me go back to, we'll do our diagram. We'll go back to our diagram right here. Okay? Remember, the ecliptic, right? The ecliptic goes above and below, by which I mean north and south of the celestial equator. So here's the ecliptic, right? Here's the path the sun takes around the celestial equator, around the celestial sphere, once a year, right? And when the sun is here, right? When the sun is as far north as it can get, that must be the middle of summer. And then the sun hits the equator on the fall equinox, the autumnal equinox, and then the sun goes south of the celestial equator, and if the sun is down in the down south of the celestial equator, that must be northern winter. And then it comes back up here, and the sun hits the equator again on the spring equinox, or the vernal equinox, right? So the sun's here on the equator in the middle of spring, north in the middle of summer, back on the equator in the middle of fall, down in the south in the middle of winter, and then back on the equator again the next spring. Okay. How does that relate to the stars? Well, let's think about the right ascension. Right? The right ascension, where the stars are east or west around the equator. So, when they were making this map, when they were inventing the right ascension declination system, they had to put 0 somewhere. Like, where should we stick 0 hours right ascension? And they decided to do that on the vernal equinox. Say, when the sun hits the equator on the spring equinox, on the vernal equinox, that'll be 0 hours right ascension. And then it'll increase. Right ascension increases as you look left, as you look east. So, how many hours of right ascension are there in the whole celestial equator? 24 hours. So it goes from 0 to 24. And it's increasing, right? The right ascension goes in the same direction the sun does, to the left, which means if this is 0 hours, then in the middle of summer, the sun is at 6 hours right ascension. In the fall, the sun is at 12 hours right ascension. In the winter, the sun is at 18 hours right ascension. And then it's back to 0 the next spring. So the sun is at this right ascension. This is how the location of the sun corresponds to the seasons, right? The sun's at 0 hours in the middle of spring, 6 hours in the middle of summer, etc., etc. Okay. How does that help us answer our question? Let's go back and read question 4 here again. Will Orion's belt be visible at night in the summer or the winter? Well, what is the right ascension of Orion's belt? Orion's belt is 5 hours, 36 minutes. You know what? Let's just round that to 6 hours to make the math easy, right? What's the right ascension of Orion's belt? About 6 hours. So, Orion's belt is right about there. Right? It's right about there on the celestial sphere. Orion's belt is right there where the sun is in the middle of summer. So we can't possibly see Orion's belt in the summer because it's behind the sun. Right? The sun will be in the way. And when will Orion's belt be up in the summer? During the daytime, when the sun is up. 6 months later, when the sun is over here, then the sun is at 18 hours right ascension in the winter. That means this part of the sky will be up in the daytime, and this part of the sky will be up at night. So Orion is a winter constellation because in the winter the sun's over here. So you're looking over here in the daytime and on the other side of the celestial sphere at night. So all of these constellations over here are going to be winter constellations because they're up when the sun isn't at nighttime. So that's why Orion is a winter constellation. Is Orion's belt visible in the northern sky near Polaris or in the southern sky from our point of view? Well, what did we say? What did we say a minute ago, right? Orion's belt is right on the celestial equator. Where is the celestial equator from Arizona's point of view? Well, here in Arizona, we're in the northern hemisphere. If we're in the northern hemisphere, if we're north on the Earth, then that means the celestial equator is south of us. And therefore, the celestial equator, like we were saying here, I really made a mess of this, right? If we're standing there in the U.S., here's our horizon, and the celestial equator is up in the southern sky. So in the winter, when Orion is high in the sky, where are you going to look to see Orion? You're going to look south in the southern sky from Arizona, because that's where the equator is. Okay? Okay. So that's how we can relate, by doing some... By knowing where you are, and saying, well, okay, if I'm right here on the Earth, then my horizon is here. That's how you can correlate the right ascension and declination of stars to what their altitudes and azimuths will be above your horizon. Because where's the horizon? It's perpendicular to wherever you're standing. And that's how you can translate right ascension and declination into altitude and azimuth, or vice versa. Okay. If that's a little tricky, and that's why we're doing it, is to get some practice. So if it's not making 100% sense right now, that's okay. Post a question to the discussion board, come into office hours. I want this to be making some sense to you before you tackle the practice. So if this is making sense, go ahead and take the Tool 5 practice, and good luck. Have a good day.